Video will show how to compute areas from a JPEG image of a watershed topographic map. It's assumed that we've already delineated the watershed, and it's a relatively quick way to compute areas and some other metrics in the absence of more sophisticated mapping tools. It uses a piece of software called Engage, which is available on the internet for free. It's governed by the GPL license agreement, which is a public license agreement and allows use of software for any professional use as long as you fully acknowledge the original software. In the DES 606 flash drive, in DES 606 programs, the Engage program is pre-installed, and so to run it we would double click on engage.exe, and doing that it would come up with this window. Next, what we're going to want to do is in DES 606 Houston modules, module 2, example 2 data files, there's a data file called ashhand by creek jpg, and that's the file that we're going to use to compute the watershed area. In Engage, we want to go ahead and import the file, ash creek by hand jpg, or we could use the png, but it may not exist on your disk, and it imports it, and it does some automated processing, and we want to view the original image. And so there's the original image that we want to go ahead and operate on. We're going to have to tell the program something about this square, and then we'll go ahead and digitize this boundary. And in the process of doing that, the computer program will give us the area of the polygon that we described, and more importantly, if we enter the units correctly, we don't have to do a subsequent calculation as is often done in other cases. So the next thing we want to do is go ahead and generate a scale bar. And now here's the deal. The length is one graph unit. It just so turns out that that one graph unit is 1,000 meters, 1 kilometer, or 0.6214 miles. By choosing this in miles, the program will automatically calculate distances in miles and areas in square miles. Choose OK, and we're ready to begin. We want to go to Measure Geometry Info, and we'll resize this. And in this cell right here, as we start to digitize, it's going to keep track of the polynomial area, and that polynomial area will happen to be in square miles, and we use that to approximate the area of this watershed. Now I prefer to start at the outlet and work counterclockwise. That's a holdover from having to do this by hand with a grid system superimposed on the map and then enter the data into a Fortran program to get areas. The direction doesn't matter, just don't change midstream. We're essentially doing numerical planimetry. So we click on that symbol, which is the measure point symbol, and start dropping points. So there's our first one, and it has an arbitrary coordinate system. It knows what it's doing, and we just start working around the boundary, dropping points as close or as far apart as we choose. The nominal area of this particular watershed, as determined by professional cartographers at the United States Geological Survey Water Science Center, is somewhere just shy of 7 square miles. Our goal here is not to replicate their kind of work per se. This would be, again, where we're having to make a fairly rapid determination without access to more sophisticated tools. To some extent, the accuracy can be enhanced by using a lot of points. It comes at a price, namely the speed of sitting there clicking on the points and generating the boundary. Okay, we got the most extreme location. Now we'll work our way back to the origin. Go a little bit outside, just make the next one same distance a little bit inside. Again, just like using a manual planimeter. That's really all we're doing here. And I've probably drawn far too many points to really make much of a difference. Certainly could have gotten by with fewer, but I want there to be sufficient time. And then as we get closer to the origin, we try right there, and this is claiming that the area we've just enclosed is 7.2 square miles. That's a little bit on the large side. What I like to do is check the X and Y. So we're minus 0.74 and 1.01, minus 0.78. We didn't quite get back to our origin. Could try that. Not much to be gained there. So the polynomial area, the area of that polygon is 7.2 square miles. The correct area for this watershed is 6.9 square miles, but given the rapidity and the somewhat rapid accessing here, this is not a bad estimate of the watershed area. And that concludes the video of how to use Engage. If there was some reason to then use these values elsewhere, we could simply copy the values, or if you actually wanted the XY coordinates of the boundary you just draw, you could copy that there. If we look at the bottom, it should account for 100% of the data, and we were pretty close with that other ending point. That concludes this video of how to use the Engage digitizing software to directly compute watershed areas.